Hey guys, so this is Vladimir Burilov again. All right, so for today's session, what I want to do is go over Twitter and see how I would architect it using AWS services. I'm also going to touch upon some of the most common questions asked during an interview, such as, how many microservices you would see here and what are some of the typical constraints that you know of and how would you work around them. So let's get started. Well, this is my Twitter account, and I haven't practiced this. I just want to do this live as though I'm doing it during an interview. So I might think about some aspects of it while I talk. You might hear, a lull between me talking, uh, between my, sentences. But the point here is I want to do it as though I'm being interviewed here. All right, so I'm being asked to create this using AWS services or how I would architect this using AWS. So the way I would approach this is I would break this down or break the screen, the UI down into components. And that's probably the easiest way for me to start with since, I only have, 10, 20 minutes, however amount of time you're giving to actually architect something like this. So this is one component, another component in the actual feed. Third, search functionality, some local trends here, who to follow these recommendations, my settings. Um, so, all right, let's start. Well, first of all, um, let's start with the actual authentication and authorization. If we're talking about AWS, then definitely look into Cognito. Amazon Cognito is the managed user directory that I would use for authentication and authorization. It provides you the functionality for basically it allows you to create the sign up, sign in functionality, and it gives you the ability to use those JWT tokens, those OpenID tokens, in your downstream services such as API Gateway, ALB, and even within your own code, it's easy to decode them and to um, make sure that it's a valid token. All right, so that's authentication for you. Now, when you authenticate, the user directory keeps your data or stores your data, it owns your data. So what I would recommend you do is you create Lambda hooks within Cognito to propagate this data, this user data, into something like DynamoDB. That's probably my go-to database for user information. So I would have a Lambda hook upon confirmation of a user that will copy the user's information, such as the user ID and the email, into a DynamoDB table, and that's my source of truth. So basically, that user ID is what I will use in my downstream services for identification purposes. All right, so I think that's done with. Well, here, I don't think we have to do anything special here because obviously it's just a menu. We're going to go into some of those components. I don't know if I want to click through my messages or notifications, but I have a good memory when it comes to those two components, so I'll just probably talk to them. Uh, let's talk about what's happening. Let's talk about me tweeting. So, first of all, where would I store all of the tweets, all of the people's tweets? Well, in multiple places, most likely. So, most likely, I would store them in a DynamoDB table in a time series kind of manner for each user. And then, so each user would have, um, there would be, let's say, a tweets table in DynamoDB. And each user is going to have his own list of tweets with when this tweet happened. And you can sort based on that value, and you can basically index. You can retrieve that data based on that value as well. And you need it probably to look at your own tweets. I don't remember if this functionality is here or not, but I'm sure it is. So if I want to look at my own tweets, I think it's organized by the date. So I'll need it to do that. I'll need to do that. Now, what happens next? Well, I see this component here, the search Twitter component. So what that means is I can search tweets, and not only my tweets, everybody's tweets, obviously. So for this to actually work, I need to propagate the tweets and the text of these tweets into something like Elasticsearch. So AWS has Elasticsearch service that you can use to store text, and that's what I would do. So once I store something in DynamoDB, I set up a DynamoDB stream, which basically allows me to propagate my records elsewhere. So in this particular case, I would propagate my records into Elasticsearch, and I would propagate them. Let me do a search here. So let's do a search. All right. So I get things that, well, first I get things that from people I subscribe to. And so this is not a person I subscribe to. So that means that it just shows me a bunch of tweets from all over Twitter. I don't know what the algorithm here is, what the popularity algorithm here is, but so let's see, and there's 1,000 likes, 600. It's not a lot. Yeah, I have no idea what the popularity algorithm here is, but basically, once I propagate the tweets into Elasticsearch, this just lets me search all of them. And Elasticsearch is great in a way where you can specify what you want to, um, which types of tweets, which types of tweet metadata you want to um, kind of elaborate on and push up or push down. By the way, here's something else that comes to mind. So when I propagate I wouldn't probably store the tweet immediately in Elasticsearch. So what I would do is from the DynamoDB stream, I would create a record in SQS, and then I would pass this record through a series of um, processes, either using step functions or just using multiple SQS queues and just managing that yourself using Lambda. Why would I do that? Well, let's think about this. Let's think about, let's say, this tweet, right? So this tweet is, let me see, a tweet with pictures. All right. Okay, this one. All right, so this is a picture. I'm assuming this is a picture. Or a link, I don't know. But let's say they posted a link, a picture, right? So yes, I can just store this text in Elasticsearch, and actually this brings me to a really good point. So I can post pictures as well. If I post not only text but pictures as well, what I would do is I would store the pictures in an S3 bucket. So I would store the pictures under a specific prefix for that specific user. That's first of all. And I would also make sure that I work with that picture. So this is the whole thing with storing the DynamoDB element in, let's say, in an SQS queue, right? What I want to do is I want to check whether I can do a whole bunch of metadata analysis on this tweet. So what kind of metadata analysis? Well, let's say first of all, I want to check the sentiment. I can use um, Amazon Comprehend to do that. I can check whether it's a negative tweet, positive tweet. Maybe this person is tweeting too many negative things, and maybe that's pushing a lot of people away. And I want to make sure that people, are still comfortable with using Twitter. So maybe I kind of um, not suppress, but maybe I show less of negative tweets. If let's say the viewers, are overwhelmed with negative tweets. I don't know. I'm just making this up as I go along. So I would use Amazon Comprehend to for sentiment analysis, and I would store this information in DynamoDB as well as Elasticsearch. So I would store it in DynamoDB and Elasticsearch as metadata because I will be able to search by this information as well. Then I would also analyze the images. I can run the images through an image analysis service, Recognition. It will get me a whole bunch of data from the image as well, such as labels. So as an example, in this particular case, I can even get serverless or live from this image. Let's say it was an image. Let's say it was not just a link. If this was an image, I can get this live session text from it, and I know that maybe this Twitter account is talking about some kind of a live session. So now those people who are interested in serverless and interested in live session, and I might look at some of their history and just see whether they love watching videos on Twitter and what they do here on Twitter. Maybe I will kind of prop this message up for them so that they see it. There's more chance of it that they would see it than not. All right, so um, what else? What else can I do here? Um, I can also, if let's say the audience is diverse and multilingual, then I can also run this tweet if it's popular enough through um, through um, our translation service. So Amazon Translate, AWS Translate. I can translate this from, let's say, English to whatever other language that this service supports. It supports a bunch of them, so I don't remember. Um, it's probably easier for me to memorize which services, which languages they don't support. But basically, that's what I would do as well for more popular tweets. All right, so what did we do here? We stored the image in S3, we stored the text in DynamoDB. Um, And actually, what I would do as well is store the text in S3 as well. So I would store the image and the text as well as in DynamoDB. The reason is I would want to create a data lake out of all the data that I have. And I might as well just store this text there um, as it comes into the system, to the ecosystem. That way, I can immediately start running um, analysis jobs and models against this data. So I can use Athena for that. I can use Glue for that. I can transform the data and things like that. All right, so we've stored the text, we've stored the image. We have created some metadata from the text and the image. We stored this metadata into DynamoDB. DynamoDB puts this metadata into another DynamoDB stream, and that stream actually is read by a Lambda function, and the data is propagated to Elasticsearch. So what does Elasticsearch have at this point of time? It has the tweets, it has who made the tweets, obviously, it has some metadata on the tweets, it has links to the images that are in S3, and it has some metadata on the images as well. And by the way, whatever you can do with the image, you can do with videos as well. If you upload videos, you can also use recognition for that to analyze the video and figure out what this video is about. So now when I do the search, when I do a search Twitter, now the data in Elasticsearch is smarter, or the way I can create my queries, um, I can add a bunch more parameters on the back end based on who I am as a searcher, and I can basically retrieve the more interesting tweets specifically tailored for me. And obviously, most of the tweets, so let's do Let's do linked in. All right. I don't know why this shows up here, but which is interesting. Yeah, I have no idea why these show up here. It's not like this is, ooh, it's not like this is anything I've ever searched for or was interested in. So I don't know. I don't know what the algorithm here is. But basically, that's how I would store data in Elasticsearch, DynamoDB, and S3. Now, what's next? Latest, well, latest, what you can do here is you can actually, um, let's see if it shows the ones that I'm subscribed to. No, again, it's also related to LinkedIn. So here, DynamoDB will allow me to, or actually Elasticsearch in this case, because I need to filter by LinkedIn. So I would have to search Elasticsearch here. Elasticsearch would allow me to search for any tweets that contain LinkedIn word, and I can sort it by the latest that was the timestamp of when the tweet was added. All right, let's do photos here. Do they actually do photo analysis? Okay, LinkedIn in the text. What about here? LinkedIn in text. Nothing here. Nothing here. All right, so this is close. Uh, yeah, still in the text. So all they're doing is they're searching for the text tweet, uh, the text in the tweet, and not really the image. So it seems like they're not doing image analysis at all. But again, for to get a bit more insights out of these tweets, I would definitely look into doing or extracting some metadata from the images themselves. All right, so what else? Well, let's look at this. Philadelphia trends. I'm actually located in the Philadelphia area, so that's why this is showing up. All this is it just shows, it just checks which IP address I'm um, accessing the internet from, and it pinpoints me to the Philadelphia area, and that's why it shows me the Philadelphia trends. I'd never specified that I'm from Philly, and it just gives me data that has Philadelphia in it, most likely, that is, either promoted. It seems like this one is promoted, or it's just, more or less interesting to the people living in Philadelphia. So there's some data aggregation, and that's where S3 comes in, actually, where you can do a whole bunch of Athena-based queries. And Athena, by the way, is a distributed SQL engine. Basically, it's Presto, and it allows you to query structured, semi-structured, or completely unstructured data that lives in S3. There's different ways of doing it, and there's a way to optimize the data so it's really, really cheap and really, really fast. So it really comes down to what your goals are and how you process or post-process this data. But you can use Athena to have a bigger picture of what the Philadelphia trends are these days, and you can store this data in, let's say, Elastic Cache. Elastic Cache is our caching service, and it allows me to, or it would allow Twitter to store data that's often accessed without overloading, let's say, again, the downstream storage services. You can't query S3 using Athena on a user basis, meaning you wouldn't want to run this for each user. You want to run it in batch because of concurrency limitations and mm, other things to worry about. But so you want to make sure that you pre-process a lot of that metadata, a lot of that data, and store it somewhere. You can store it in Elastic Cache. You can also store it. You can also cache it in CloudFront. So as an example, let's say you have a user who's in Philly who brought up twitter.com, and it was the first time somebody from Philly brought up Twitter today, as an example, or within the last hour, as an example. So what would happen is, let's say this request from the website is going to go into one of the microservices responsible for this particular data. This microservice is going to take this request and it's going to kick off some kind of a um, data aggregation process. This data aggregation process is going to run and it's going to return some kind of data, right? Uh, but if the request went through a CDN like CloudFront, which is our CDN service, then the AWS CDN service, then the CDN can actually cache it, and especially since this is really region specific, it can cache this request or this output, and it won't even hit these backend services for a certain period of time. So everybody from Philly looking up this particular or bringing up twitter.com would get the same result. Now, what this really means is exactly what I said. They would get exactly the same result. So there's no customization here if that would be the approach. But if you do want customization for each specific user, even though I don't see any customization here because really I don't know why this is showing up here. I have no idea what against flyovers when the planes were flying over today and in this together I have no idea why it's here. I don't know. So it doesn't seem like there's personalization, but let's say I do want personalization, then I would have to actually generate this data on the fly. And then I would not use uh, CloudFront caching for it because it makes no sense because it's personalized to me. I can actually cache this in my browser, which I strongly recommend you do. Cache whatever you can in your browser, such as this data, so that next time, let's say I go back to twitter.com, and if let's say I was on twitter.com 5 minutes ago, and this section probably doesn't change every 5 minutes, then it won't regenerate, it won't hit my backend services, and I'll just retrieve this data from the, the local cache. All right, what else? So again, this search is one set of microservices. Uh, this is another set of microservices. It's one or many microservices. Search is definitely more than one microservice. Because again, I'm not even counting all the microservices that need to handle the actual aggregation of data and the actual processing and pre-processing of data. All I'm doing here is just talking about the microservices that accept your RESTful request to search for something specific. So maybe in this particular case, this might be one microservice, this might be another microservice, this might be another microservice specific to the item at hand. Because let's say searching people is technologically and data-wise is completely different than searching, let's say, photos, because photos involve so much more data analysis, image analysis, right? Than searching people. Okay, because searching people here, I can just type in LinkedIn and it might be just a simple, Elasticsearch search. All right, what else? Uh, so what happens with the more popular people? I know this is a question that has been asked on some interviews. So what happens, let's say, if Trump tweets? Uh, what happens in that case? Well, if Trump tweets, then obviously it's a good idea to cache it. It's a good idea to cache the tweets of the most popular people. Why? Because you would overload your system really fast. So I would say that there should be a threshold that should be set for the more popular people. And so let's say if somebody is being subscribed to more than 20,000 times or by more than 20,000 followers, as an example, then in that particular case, I would store this particular person's tweets in. I would actually store the tweets in CloudFront. And here's why. I would store it as, let's say, a list, right? As a list of tweets. And then I can let the UI for each particular user to determine which tweets to display and which not to display based on previously displayed tweets for that particular user. The reason is simple. I mean, think about how many tweets Trump is, how many followers Trump has. Well, let's search for Trump. Donald Trump. He he has 78 million followers. All right. So since he has 78 million followers, that means that uh, a significant amount of Twitter is actually getting his tweets, and every single time that, let's say, a Twitter user brings up the UI, that means that there needs to be a uh, a read on Trump's, you know, row, and that might that might actually cause read capacity issues, right? So let's say if you store everything in DynamoDB, um, or even if you store it in Elasticsearch, right? Even if you don't go through DynamoDB initially, but you go through Elasticsearch, when let's say even 5 million people trying to read or bring up their UI and they want to see what Trump wrote, that means that 5 million requests need to happen against Elasticsearch. Yes, you can have caching there, you can have Elastic Cache, you can store those tweets in Elastic Cache, but that's still 5 million requests to Elastic Cache. So you can unload Elasticsearch from these requests, but now Elastic Cache is going to be loaded or overloaded. So why not just move it to CloudFront? You can basically you can force CloudFront to have this value. So within the UI will need to know that it's that this particular user is subscribed to, let's say, Trump, or maybe there's a way to kind of indicate that some of those users that this user is subscribed to are more or less popular. Uh, and maybe what can happen even is you can, even if the UI doesn't know, then what can happen is with the first request of get me all of my tweet page or my tweet wall, with that request, um, maybe the backend service, the first initial proxy backend service, will determine um, who the user is asking for, and then some request will go to CloudFront and just actually no, that makes no sense because if the request is already on the backend, then CloudFront's usefulness is diminished, right? So yeah, I would think about how I would retrieve this data. I'm still leaning um, towards having some kind of a list of popular users uh, that I cache on the UI, and then I would simply call some kind of a CloudFront fronted service to retrieve the tweets for those users. Probably would do that. And again, guys, I haven't prepped for this. I just want to make sure that I go through the same steps that an average Joe goes during an interview. And I'm just thinking out loud. And usually during an interview, somebody might, kind of force me one path or another path. So it really depends on um, your interview process. But this is where I would start and then see what you get as feedback. All right, so let's see, logout again. Since all of this is cognito, then you just log out, you log this user out, and no longer will the JWT token stored in your browser work anymore. So uh, your downstream services actually will need to do periodic checks. Well, what we can do here is if you log out, then you would remove your Cognito session completely. The UI, the JavaScript code will remove those JWT tokens, so they're not cached anymore. So the UI won't have these tokens at all, because otherwise, for the period that this token has been generated for, the token itself will still be valid. And the only way to figure out whether the user has been logged out is to actually talk to Cognito. And that might cause additional calls to Cognito, which you don't want to make. So, you clean out on the UI side, and you're kind of closer to achieving your goal here. All right, what else? Notifications. Well, notifications, man, I'm afraid to click on this because I don't know what notifications I have. All right, let's do this. All right, so notifications such as, somebody liked my post, or somebody liked the post that I'm tagged in, um, somebody replied to me. I mean, these are quite easy. You're just, if something related to me has been created, if any content related to me has been created, then I would have a DynamoDB table, sort of like a grid table. Think about user and then um, a column for each type of notification, and then the actual notification stored maybe within the actual DynamoDB table or somewhere else, maybe in another DynamoDB table, uh, with the details of what actually happened. So as an example, let's go through this. Let's say somebody likes my notification, or somebody likes my tweet. Well, what happens there? So there's a row with Vladimir there, and um, the new row entry would be, or the type would be liked, and then I would provide maybe some additional information such as um, liked, and then which tweet was liked. Um, that in turn would be propagated to a DynamoDB stream, and then I would read from that stream, populate some kind of let's say I populate an SNS topic, or I can populate just an SQ, and then another Lambda function. Well, let's think about this. I populate a queue, a Lambda function reads from that queue, and the goal here is I don't want to make too many pushes to the website, right? So what I want to do is, if I have a connection established between the website, the Twitter website, and the backend, well, it doesn't really matter then how many pushes I make because the connection is established, so I'm already eating up the resources. Um, yeah, it doesn't matter then. So I would just propagate this data to an SQS queue, and then I would have a Lambda function pushing these messages um, to a service that can propagate um, the push up to the website. So I'm not sure how Twitter does it. I'm not sure if there's a connection established between, if there's a subscription established between from the website to some kind of a backend service so that the pushes happen, um, or if it's a pull request, meaning if let's say Twitter just periodically pulls or calls some kind of a backend service and to see if this particular user has any new notifications. If it's a pool, then I wouldn't need the Lambda function SQS. I would just store this data in, let's say, a DynamoDB table, or I would aggregate this data um, and store it in, let's say, Elasticache, as an example, or in another DynamoDB table. Saying that well, he has 3 likes and whatever other notifications, and then the uh, UI gets this information, and then it knows how to display this information. All right. I don't know. I think I rambled a little bit about this whole solution, but again, I just wanted to make sure that I didn't think too much about it before this actual recording, so as to come up with a solution in a kind of a more realistic way. Hopefully this helped. I mean, this is kind of architecture 101. I've not discussed, I would say, 70 or 80% of other services that are needed in order to make something like this work. So as an example, I didn't talk about AppSync, which would allow Twitter to retrieve data in a smart GraphQL kind of a way. I didn't talk about um, what else? I didn't talk about these messages, so how to set up or how to basically create chat communication between users. So there's a lot of components that I didn't mention here. But hopefully this was a start. Hopefully you find this useful. If you do find this useful, please subscribe. Please like this video and please share it. If you haven't found this useful, let me know why. Let me know what I should change or what I should improve upon, and I'll take it from there.